Hi, this is Brent, and in this video we're going to go through the data modeling, custom types, and Swift testing, and we're looking at add functionality with Swift testing. So in this one we're continuing with the project that we created in the last tutorial. If you didn't do that one, you can download the project files from this tutorial, and then that'll get you started. Or if you already have the project from the last video, we'll go ahead and open that. So let's go over to Xcode and let's open our scorekeeper project. You remember from the last tutorial we created this simple application that allows us to add players and lets us update scores and things like that. In this tutorial we're going to add some more functionality, and then we're also going to explore Swift testing, which is the test framework, the newer test framework that is available in Xcode. And we're going to use the testing in order to create the functionality. So we're going to go through and do a number of things, and we'll talk through them as we go, because a lot of this will be fairly new if you haven't done any programming. And so just follow along, and I'll try to explain things as we get through them. First thing we're going to do is we want to create a new file, and we'll right click on the folder. We'll say new file from template, and this will be a Swift file. So under iOS and then Swift file, choose next, and then we're going to call this scoreboard. Let's go ahead and create a struct called scoreboard, and we do the opening curly brace. We're going to use this file to model the logic of our application. And when we do this, where we don't have any UI associated with the logic, we can then use testing in order to validate the functionality that we have. And so I'll explain that as we go, but just keep in mind that we're creating a custom type that allows us to run the logic of the application, so then we can test it in the future. Let's create a variable that we'll call players, and it's an array of player objects. And this is similar to what we've created already. So we can actually go over to our content view and we can copy this and go back to scoreboard, and then I'm going to select the braces and the square brackets and paste it. So what I've done is I've created an array of players that's now associated with the scoreboard. In a little bit we're going to refactor the content view so that we can replace the variable that we have here. If we go back to the content view, we can actually add a state variable that references the scoreboard. So we can say at state private var scoreboard equals scoreboard. Now, in the tutorial, it talks about the refactoring that we're going to do. And this is a different way of making changes. Before, in the previous video, we were making changes and then we would get a bunch of compiler errors, and then we were fixing those errors by replacing the content as we went. I'm going to do it differently. In this tutorial, the instructions talk about making the changes as you go so that you're not dealing with as many compiler errors. So it's a slightly different approach. Since we have the players object in the scoreboard, we can update this. Before I delete this, which we will delete it in a second, before I delete it, what I'm going to do is go through and replace references to this players and replace it with the scoreboard dot players. So we're going to say scoreboard dot players. Then down in the button where we were appending players, we're going to update that to say scoreboard dot players. So now we're referencing the players property that's on the scoreboard object. So now let's go ahead and delete this players variable, and notice that the app continues to run. Let's go ahead and make sure that everything is working, and we have the same functionality. So now we've refactored that to use the players object that's on the scoreboard, and that way we were able to refactor it. We didn't get as many errors because we were basically replacing it as we went along. Now we want to add some more functionality to our application. The first thing we're going to do is create what's called an enumeration, and it's going to represent the various game states that the app can be in. So come over here to Scorekeeper, right click, choose New File from Template, and again we'll create a Swift file and choose Next, and we're going to call this Game State. And then we're going to create an enum, and we'll call it Game State. So the difference between a struct and an enum is a set of predefined values that won't change as the app is running. We use a struct or other types if the values are going to change. And so you can think of an enum as a list of static values that you can reference within the application that are hard-coded into the app. The other difference between a struct and an enum, with an enum you can only have one instance of it. So those values are declared once and used throughout the application, whereas struct you can create instances of that struct and use those like we did with the player struct. We create multiple players within the application, whereas on the game state, we are going to have a list of states that there's only one set of values. So the way it works is in an enum, you declare a case, and so you give it a name. So we're going to say setup is one case, another case is playing, and then another case is game over. And we can capitalize the O. So what we've done is defined the game states that the app can be in. And what you will see is we will modify the UI based on the current game state that we're in. Let's go back to the scoreboard. And here we're going to add a property called state. So we'll say var state equals, and we'll call it gamestate.setup. So this will be the initial value, kind of a default value of state. Now let's go back to the content view. And from here, let's add some more UI elements down at the bottom. Under this spacer, we're going to use a switch statement. And let me explain it once we get through this. So go ahead and type switch, and then we're going to say scoreboard.state. And then let's go ahead and use what's called a default, use a colon, press return, and then empty view. A switch statement is similar to a series of if statements. So it will iterate, the switch statement will iterate over each of the items in a given value, and then based on each value you check against, you can have it do certain things. So if the scoreboard.state equal to certain value, you would do a certain thing. Right now we're using default because the switch statement needs to completely cover every item that's possible, every choice that's possible, or it needs to have a default. And in our case, we have a default, and so we can leave that here and it still compiles. While we're doing this, we're going to be making some changes, and it'll become clearer as we go, but for now we're going to add one thing at a time. So the first case we want to say is .setup, and then a colon, press return, and then we're going to show a button. So we're going to say button, and it's to be called start game, and then comma system image. we're going to say play.fill. And then in the action, we're going to say scoreboard.state equals dot playing. So we've added this button, and when you press the button, it's going to change state, and it's going to set scoreboard.state to dot playing. Now at the moment, we don't have anything else to show because the default, when it goes through, is to show an empty view. So right now we don't have anything else. We'll fix that here in a second. Let's add another case. So we use the keyword case dot playing and then a colon. And here we're going to show a button and we'll call it end game. Then a comma, then system image, we're going to use stop.fill. And then in the action closure, we're going to say scoreboard.state equals dot game over. So now, can you guess what's going to happen? So if I press start game, notice that it then shows it switched to dot playing, and so now it shows a button that says end game. But guess what happens? If I press end game, it goes to the empty view because we don't have a state, we don't have a button showing for the game over state. All right, so let's go ahead and add that. So we say case, lowercase, case dot game over, colon, and then we show a button and we call it reset game, then a comma, and then the system image we're going to use, it's going to be arrow dot counterclockwise. Oh boy, I got to spell it. Counterclockwise. And then in the closing block, we're going to, guess what? We're going to set the state back to setup. Okay, now notice what happens. We get a warning, and in the warning it says default will never be executed. And because, remember the state property on scoreboard references game state, and game state has three cases. Whenever you have a switch and you're switching, you're going through all of the elements of an enum like this. There's three, in this case, there are three cases. So what that means is we have now, the switch statement is now exhaustive, meaning every option is covered. And so this default will never get landed on. It'll never come to that point because everything is covered. So it gives a warning. In that case, we can go ahead and delete that. Oops, did I delete too much? Yep. Oh, I deleted too much. Delete just those two. Perfect. So now, notice the button changes to end game, and now when I click end game, it goes to reset game, and then when I click reset, now it goes back to start. Let's go back to the scoreboard, and we're going to create what is called a mutating function. Now, let's type this out and then we'll talk about it here. So go ahead and type the keyword mutating, and then the keyword func, F-U-N-C, and then we'll give this a method and name, reset scores, and then open parentheses 2, and then a space, new value of type with a colon, and then of type int. So what we've done is we've created a function that's on the scoreboard, and it will be called reset scores, and then we pass in a value that we reset the scores to, at which point we use the keyword mutating because anytime you have a method on struct that changes the values of its own properties and methods, or sorry, properties on the scoreboard, you need to use the keyword mutating, because it's changing itself. Referring to the tutorial, it talks a bit about when we talk about functions, if a function is on a type, so right now we've created this custom type called scoreboard, and because we have a custom type, any function that's associated with that type is referred to as a method. So reset scores is a method of the scoreboard type. It gets a little confusing, and I may mispronounce it or talk about it incorrectly, but just understand that you've got a function that's associated with a type, and this is referred to as a method related to that type. Now we're going to go ahead and work with the Swift testing framework. And at the moment, all of these like this method is empty. And right now, when you look at the content view, these buttons really don't do anything. Nothing changes except for the button itself. The button changes here, but there's no action that's affecting our application. So what we're doing is we're going to use what is called test-driven development. We're going to write a test. The test will fail because right now on the scoreboard, there's nothing in this method. But when the test fails, then we go and we add the functionality, we make it work properly, then the test will pass. And that's referred to as test-driven development, where you write the test first and the test is failing, and then you implement the code, and then the tests will pass. It'll make sense as we go along, but the next step is we need to add another target to our application to use the Swift testing framework. Before we get to that step, let's go back to the content view. Let's add a few more properties. We're going to add a private var called starting points, and we're going to set that to 0. And then we're going to use this value to keep track of every time the game resets to understand how many points that the players start with. And so we need a variable that we can then modify. And we set it as a private var on the content view because the scoreboard will make an update based on that value. When the game starts, we need to reset the scores. And so what we can do is call scoreboard.resetScores2, and then we can pass in the starting points variable. And then it's going to reset the player scores. Now, remember, this method doesn't have anything in it, but we're going to implement that next. In order to add the testing framework to our project, we need to click at the top level. So notice the scorekeeper. And then over here on the right, notice that we have the project listed at the top, and then we have targets. Right now we have a target that is running on iOS devices. And if we want to add another target, we can click this plus down here at the bottom. And what we're looking for is referred to as the unit testing bundle. And it's this one down here at the very bottom under the tests. And so go ahead and choose next. And we'll keep the name, and we've got the project, and go ahead and choose finish. So now it's added another target. And the reason we use targets is so that you can compile and run this without actually having to run the entire app. And so here on the left, we have these folders, and we've got additional things so that we can run just the tests, and it will build it and run it, and it's separate from the actual application. So when you go to deploy your application to the App Store, you're building just the main application, and you don't have to worry about the tests. But the tests can be run while you're developing the application. If we take a look at this, it's got a few new things that we haven't seen before. We have this @test annotation, which means that this is a function that will run as a test method whenever when this target is run. And then you have a keyword async and throws. And those are features that are used in the Swift language when you're dealing with concurrency, whether you're waiting for things to happen on the network or if it throws an error. So when you're dealing with error handling. We're not going to cover those in this tutorial, but there's plenty to read up on. And the tutorial references some additional things if you want to look into more about testing. For our purposes, let's go ahead and change this a little bit. You can add, you can pass in a name to the test where it says, we're going to say reset player scores. And this string is used so you can actually see when you're running the test, you can see which one is being run. And then we want to change this function name to reset scores. At the top of the file, we want to import the scorekeeper. We need to use another keyword called @testable, and then import, and finally we want to import scorekeeper, which is the project that our application is. So what this does is it allows us to reference code in the project and allows us to run tests against it. Whenever we write tests, we need to initialize the code that we're testing. So if we're passing, in this case, we're testing the reset scores method, we need to create a scoreboard object and players, and then we're going to call the method, and then we're going to make what they call an assertion. We're going to use certain testing methods that will say, when this runs based on this information I expect this result. So the first thing we'll do, let's go ahead and delete this comment, and let's create a variable called scoreboard, and we'll create a new scoreboard and pass in players, and we're going to have an array of players. And so we'll say player, we'll say Elisha, and a score of 0, and then a comma, and then we'll have another player. And remember, I'm just using the tab key to auto-complete, and then it jumps to the next value that needs to be filled in, so I'm kind of going through it a little quickly. But remember, if you press the tab key, then it jumps to the next value that it's expecting, and in our case, we'll go ahead and set that to 5. And then from here, we'll call the method on scoreboard dot reset scores to, and then pass in a value. After we call that method, then we're going to go through and we're going to loop through each player. So we're going to say for player in scoreboard dot players, we're going to call, there's the hash symbol and then expect. And what we're checking is that the player.score equals 0. So again, what's happening is we're referencing, we'll talk about these errors here in one second, but for now what we're doing is we are looping through each player, and then we call the expect method, which is a test which asserts that the player score is going to be equal to 0. So that's the test. That's what we're evaluating to make sure that our code is working. Now, when it talks about this instance method, what needs to happen, what we need to fix this is we just need to say await. Okay, so the tutorial doesn't mention this, but looking up online, it's referring to, because we're referencing Swift 6, it's expecting this await call, because I don't know the exact details. I'll have to look into it. We'll talk about it a little bit later, but for now, if you want to get rid of those warnings, you can just pass in await. Let's go ahead and run these tests. Now remember, this method, reset scores, doesn't actually work because we don't have anything in it. But the reason we're writing the tests first is so that when the tests run, we know they're going to fail. So to run the test, you can say product and then choose test. Now when it runs for the first time, it's going to build the application, and then it's going to run it, and it's going to be running it in the simulator, and so it may take a little longer the first time you run this. Notice up here, you'll see kind of the status. And so again, the first time it runs, it's going to build the application, install it on the simulator, and then it's going to run it. And so here, it failed, which is what we expected. And then if you come up here, you can kind of see where it failed. And it's saying it expected 0, but it got 5. So it obviously didn't reset it. Let's jump over to the scoreboard and let's implement this. So we're going to have a for loop. We're going to say for index in 0 ... less than players count. And then for each one of these, we're going to say players index score equals 0. What it's doing, the way this for loop works is we have this index, which is a variable, and the index is going to start at 0. And so the first time it runs, this is accessing the players array and is saying, give me player at index 0 and check their score and set it equal to 0. So Elisha is the first player, so their index is 0. Then it's going to go until it's 1 less than the players.count. Remember, in the previous video, I talked about the index, the array. A Swift array is 0 based, meaning the first index in an array is 0, and then the next value is 1, and the next value is 2. When you say .count, it returns the number of elements in the array. Well, the total number of the elements is 3, but we don't have an index value that is number 3. So we want to reference, we want to go from 0 to less than the player count. So 1 less than that, so that is 0, 1, 2. And so now that will reset each score. So let's go back and let's run the test again. Again, the second time you run it, it goes faster because the app is already running. So now if we jump over here to our tests, you'll see that you get these green indicators, and that means that all the tests have passed. For our testing, you could, write multiple tests and pass in for each value. So let's say you wanted to test against certain values. Instead of writing multiple functions, what we're going to do is we're going to pass in various parameters to the same function to test against each value. So to set that up, what we need to do is in our reset scores, we want to be able to pass in a value. So we're going to say new value, which is of type int. And then where we're referencing it, we're going to say we want to set the value to new value here, and then set it to new value right here. Now, we've got an error because when we call this method, we don't actually have any parameters. And so to fix that, we use what's called an arguments. And so we say arguments, and then we pass in an array of arguments. So in our case, we're going to say 0, 10, and 20. So now we can run this test, and it's going to run it for however many arguments we have, which we have 3. So it's going to run it 3 times. And then let's see how that works. When we test this again, let's notice what happens. Okay, notice that it has failed. Now the reason for that is because we haven't updated the reset scores to take that new value properly. So at the moment, what happens is when we reset the score, we reset the score to a 0, And so the first test passes. Notice it has the green check, but the other tests, when it checks against 10 or 20, it fails. If we fix that, we go back to the scoreboard. And again, notice here, the method was setting everything to 0, but now we want it to set it to new value. Go ahead and run the tests again. So click Product and Test. And now notice the test succeeded. If you come over to the Test tab, notice all 3 iterations of that, all 3 arguments have passed. Next, we want to add some more UI and functionality to our app. So let's go back to Content View. And at the moment, remember you can press refresh. Whenever you run the testing, the test will take over the simulator and then the preview stops working. So you just have to refresh the preview. We're going to go ahead and add another UI element so that we can set different settings for different types of games, whether you want the starting points to be different or whether you want the player with the most points to win or the player with the least points to win. So we'll make it more functional. First thing we want to do is create a settings view. So right click on the Scorekeeper folder, go to New File from Template, and this one we want a Swift UI view. Choose Next, and we're going to call this Settings View. Let's wrap this text in a VStack. So you right click on the text and then choose Embed. And now we can say VStack. And let's set the alignment. We don't need all of that. We just want to set the alignment to dot leading. And let's give ourselves some padding. Then let's change the text to game rules. And let's set the font to headline. And then let's give ourselves a divider. We want to add a property that we can reference outside of the settings view, and we're going to use another annotation called @binding. And then this will be a var, and it'll be starting points, and it'll be a type of integer. Now we're going to get an error. We'll fix that here in a second. But binding is a keyword that allows you to bind this property, and it's going to be changed outside of this view. So what that does is it allows you to set the property, and then the binding can be updated outside of this view. It's different than the state because it's not a state variable, is unique to that specific view and only happens within the view or its child views as they call it. And binding allows you to then modify it from other places like our scoreboard and other places in our application. Now to fix this, we need to do a few things. One, we add what is called a previewable @state var called starting point, and we'll set it to a value. Then we pass that into the settings view by setting starting points, and we'll bind it to starting points. Now, this is unique to only the preview. So this text, this code here only runs when you're in the preview of your application. Below the divider, let's go ahead and add a picker. And the picker we're going to call starting points. And the selection, whenever you select an item from the starting points list, it's going to be bound to the starting points. And then we'll do a closure, and inside there we'll add 3 text views. So again, when you make a selection on the picker, it's going to update this value called starting points. Let's go ahead and add the text. So we're going to say 0 starting points, and then we give it a tag, and the tag will be the value when that is selected. And in our case, we want to set it to 0. This text will say 10 starting points, and we'll set its tag, and yes, you guessed it, it's going to be number 10. And then we have a third text, and we're going to call that 20 starting points, and its tag will be 20. Let's update this view so that when we add it to the main application, it'll have some style to it. So we're going to use, we're going to set a background, and we're going to set dot thin material, and then we're going to say in, and we're going to pass in a dot rect with a corner radius of 10.0. So it's hard to tell right here, but there is a slight corner radius on this gray background. Let's go back to the content view, and let's update this starting points. We're going to add a state wrapper to, so now it's state private var starting points. Then underneath the scorekeeper text, let's add our settings view. And then we pass in, we bind it to the starting points here. So that's the initial state. And so when you click that, you can see the picker, which allows you to pick different values. And that's how that works. Next, let's add some functionality to our scoreboard so that we can declare a winner. And we first jump over to scoreboard, and under state, we're going to create a var does highest score win. And we're going to set that to true. And now we can update the UI based on whether the high score wins. We can add another property called winners, and for now this is going to return an array of player objects, and in our case we're going to return all the players. So this property currently is going to return everybody as winners. We're going to update that a little bit later. We want to be able to test this functionality, so let's go back over to the scorekeeper tests.swift file, and let's add a method called @test, and we're going to call it highest score wins. And so then we have a function we call the func keyword, and then we say highest score wins. We can then set up, remember we set up the values of, we set up the condition, and then we call the method, and then we check for what we expect it to be. So here we're going to set up a scoreboard. So let's say let scoreboard equal scoreboard, open parentheses, and then press return. We're going to say players, colon, and then use the square bracket. And then we're going to pass in a player, and we're going to say Elisha, and give starting score of 0, press comma, and then we have another player, and we're going to say name is Andre, and score will be 4. We do a comma after the array, and then we pass in the state, and we're going to call it the game over state, and then another comma, and then we're going to pass in does highest score win. We're going to pass in true. Then after that, we're going to say let winners equal scoreboard dot winners. Uh-oh, I got to spell it right. Scoreboard.winners. And then we use the expect method. So # expect winners equal, and then we do an array player name Andre, comma, score 4. Put a colon after that. So now it's throwing an error because we haven't set up player to be set up to be equal. We're going to fix that here in a second. Let's go to the player object, and we want to create an extension. So down here below the struct, we're going to say extension player equatable. The way this works, when you're creating a custom type, by default, the type can be set up as equatable when you have this protocol. When you say player is equatable, then what it will do is it will evaluate everything, every property that has to be equal. We don't want it to match every property exactly, because when you create a player, you have a player that has an ID, and the ID will always be unique. The name and score could be the same. So back in our test, what we're trying to do is we're going to see, in this case, we're saying that Andre should be the winner. And so we're trying to compare whether the winner array contains one person, which is Andre. And so we want the name and the score to match, but we don't want the ID to match because that's not what we're testing. So if I go back here, then what we need is to create a specific method for equality, for the way that we want it tested for this specific type. So to do that, we're going to use static func equals equals. So that's the name of the function. We're overriding the default equals comparison function, and we're going to create one. And so we do an open parenthesis and we say LHS colon space player, and then comma RHS colon player, and then that's going to return a Boolean. And now in our method, in this function call, we're going to create our own equals check. And in our case, we're going to say if LHS.name is equal to RHS.name, and we use 2 ampersands, LHS.score is equal to RHS.score, then it's going to return true. So let's talk about this. You probably guessed what this is, LHS and RHS, which means left-hand side and right-hand side. And so it's taking a comparison. When you use the equals, the double equals sign, you have a left-hand side and you have a right-hand side. What we're saying is if the left-hand side name is equal to the right-hand side name and the left-hand side score is equal to the right-hand side score, then we are saying these are equal. So we've defined our own custom equal check. So now let's go back and let's run. Well, actually, if you go back to the scorekeeper test, you'll notice that the error went away. If we test this, we can say product test. It builds, and then the test fails. Because remember, we actually haven't set the method, because right now the method returns all the winners. While we're here, before we fix this one, let's add another test that we can test for the opposite of this, which is lowest score wins. So we have a test method, so we say @test, and then we give it a name. We're going to say lowest score wins, and then it's going to be a func that lowest score wins. And then we set up a scoreboard. And we have our players, which is an array of player object, and we're going to say player Elisha, and the score is 0. And we can actually copy this from the top. Now that I pay attention, press Control C. Now, what we're going to do is change this so that does highest score win. We're going to say that, change that to false. Then we get our winners, and then we pass the expect winners equals player name is Elisha, has a score of 0. So that's what we expect. If I run this again, we say product test. Notice again, both methods fail because we haven't implemented it. So a reminder, this is referred to as test-driven development. We're creating the test first and it's failing. If the test passes, then you've done something wrong because we haven't implemented it yet. You always want to start with a failing test, then implement the code, and then it should pass. So let's go over to scoreboard. In the winners property, we're going to calculate everything here. And the first thing we want to do is we're going to use a keyword called guard. Guard state equals dot game over. Else return an empty array. So guard is a shorthand. Also notice we didn't have to use the return keyword, but now we have to use the return keyword because we have more than one expression. And so we have to use the keyword there. So again, let's look at this. So guard is safety. It's a way of checking that something is available before we run the code. Otherwise, if this doesn't exist, then it exits this and it won't try to run code on something that's not available. So we use guard state is equal to dot game over. If the state is not dot game over, then we want to return an empty array because the game hasn't been played yet. So if it is game over, then we can go ahead and calculate it. And one way to do this, we can say we want to keep track of the winning score, and we'll start at 0. And then we're going to say if does highest score win, we're going to run some code. Else, we're going to run some other code. If we are doing the does highest score win, we're going to say winning score equals int.min, and then we're going to loop through each player in players, and for every player we're going to say winning score equals whichever is higher, the player dot score versus winning score. Now let's talk about what's going on here. Int.min is a value that is the lowest value you can have of an integer. It's a helper function that's going to allow you to compare against something when you start. What we're doing is for every player in our array, we're taking their score and we're comparing it to the smallest value we can. And if it's higher than that value, then we set the winning score to whatever that player score is. And so we're checking, is this player score higher than whatever the minimum is, which in this case, it's like, I don't know what the number is, but it's really, it's a negative number because integers can be negative. But it's the idea that whatever happens is going to be higher than the starting point. So then again, so imagine this is the first player. So Elisha, it's going to take Elisha's score, and they're going to say which one is higher, Elisha or, in this case, is int.min. And so for here, we're going to say, oh, well, that's 0. So that's the highest score. And then it's going to keep going and identify it. It's going to set the highest score. So once we know who has the highest score, we're going to add some code here, and then we're going to filter for that highest score. Now, if we're talking about the lowest score, then we do something similar, but instead we set the winning score equal to int.max, which is the highest value that's available. And so we say for player in players, the winning score is equal to the minimum, the smallest value of player.score compared to the winning score. So this is going to loop through and identify what the highest score is at the top. And here it's going to loop through and find what is the lowest score that is available. Once we have that value, then all we need to do is filter the players against who has that winning score and return the players that have the winning score. It's possible that you could have more than one person with the highest score or more than one person with the same lowest score. So it's going to return everybody who has the winning score. The way we do that is we can actually set it on our return statement. We can say return players.filter, and then we're going to call a method. And in that method, we're going to say player in. And here, we're going to say player.score is equal to winning score. So what this does is it takes the list of players and it only keeps those who have a score that matches the winning score, which we calculated up here. Let's run our tests again and see if we did that and if it fixed it. Okay, it looks like the test succeeded. So again, we have highest score wins and lowest score wins, because now we've implemented the code and now our tests are passing. Let's go back to the content view. And now that we can calculate the score, we want to indicate who the winner is. And if there's more than one winner, we'll show who the winners are. First, in our grid row, we've got our text, let's see, right here, where we list the name, the player's name. Let's wrap that in an H stack. We're going to check each player and see if they are in the winners array. So we say if scoreboard.winners.contains player, then we're going to show an image, and it's going to be system name crown.fill, and we're going to set the foreground style to yellow. So what that means is when we create this for each view and we're showing each one of these, they're going to check that if the user is a winner, if the player is a winner, then we're going to show an image before their name. We can test this by starting the game and then giving some players some points and then choose end game. And notice it evaluated it and Jasmine's the winner. We can reset the game. We can change the points. And if everybody has the same points, sorry, we got to start the game. Start the game, give everybody the same points, and everybody's a winner. Let's go to the settings view, and we want to add another value. And so we're going to add another binding, and we're going to call this @binding var does highest score win and set that as a Boolean. And once we do that, then our preview shows an error, so we need to fix that. We can again create a @previewable. So the keyword is previewable, and then @state var does highest score win, and set that to true. And then we need to pass that in. Does highest score, and then we're going to pass in does highest score. Now, when I auto-completed, it added a little extra. So let's delete that. We only need it once. Okay, so now that fixes the view here, but now we're getting an error in the app. So let's go and fix that. If you go back to content view, you'll see that, oh, when you pass in the settings view, it's expecting a value. So we can say, does highest score win? And the value is going to be bound to scoreboard dot does highest score win, and then a comma. And now it satisfies that for the settings view. Go back to the settings view, and now in our VStack above the picker for the starting points, let's add a picker for the win condition. So we're going to say win condition, and then selection is going to be bound to the does highest score win, and the values that we want are text highest score wins, and then a tag of true, and then another text that is lowest score wins with a tag that is false. So now you have two pickers, one for lowest score, one for highest score, and the other for the starting points. And let's go back to content view and see how that looks. So now you've got those options. Let's see, make sure everything works. So if we say lowest score wins, and then we start the game, and then let's give some people some different scores, and then we choose end game. Notice Andre wins because they've got -2, so they got the lowest score. If I change it to highest score wins, it because we were in the game over state, it updated everybody. But if I reset the game, if I start a new game, and also let's check out our starting points. Hey, we're all winners. So start, and notice the starting points are set, and end the game, and Andre wins. Let's wrap this up. We're going to clean up the UI a little bit. First thing we want to do is in the settings view, we want to disable the settings view if the game is running. So what we can do is add a modifier called disabled, and this will be disabled if scoreboard.state is not equal to .setup. So now what that means is when the game starts, the settings view is disabled. So now we can't make any changes while the game is running. And when we end the game, we still can't make any changes. It's only until we reset the game that we can now make changes. We also want to, under the name, the text field, we want to disable, we don't want people to be able to change the name while the game is running. So if we type disabled and then we say scoreboard.state is not equal to .setup, then we can't edit the name. So for example, you remember we can edit a player's name, and when we start the game, then we won't be able to edit their name while the game is running. We can also set the opacity on the score text. So we can say .opacity, and we can say if the scoreboard.state is equal to .setup, then we'll set the opacity to 0. Otherwise, we'll set it to 1. So what we're doing is we're hiding these values while the game is in setup mode because there's no reason to have a score until the game starts. So we'll do that for the score text, and let's do that for the player's score. Opacity, scoreboard dot state equals dot setup. Then we the question mark, and then we set it to 0 or 1. And we can also do that for the stepper. We can say dot opacity scoreboard dot state is equal to dot setup. We're going to hide it, so 0, otherwise it's 1. So now, while we're setting up the game, we don't see the score, we don't see the stepper, we don't see anything. It's only when we start the game, then we see these values. We're unable to make changes to the rules of the game, and then we can interact with this as expected. We also want to hide the add player button. So we can say dot opacity if scoreboard dot state is equal to setup, then we make it visible. Otherwise, we hide it. So now, if I start the game, notice the add player button goes away, so that won't change anything. Finally, for these buttons here, let's wrap the switch in an H stack. So we're going to say H stack. And what we're doing is we're wrapping this in a stack. And from here, we can then add a spacer at the top and a spacer on the, well, it's not the top, it's actually on the sides, right? Because an H stack is a horizontal stack that goes left to right. So when you add a spacer on the beginning of it, it pushes everything to the right, and if you put a spacer on the end of it, it pushes everything into the middle. So now the button is in the middle. And then finally, we can also add styles to the H stack so that we can actually stylize all these buttons. So we can say button style is bordered, and then the button border shape is capsule, and the control size is .large, and then the tint is blue. So notice how we were able to change that. And so now every button in the games, whenever based on the state of the game, is this style. Okay, we covered a lot. This was a long one, but you got through it. Thanks for sticking with me. Let's go ahead and take a look at the tutorial, and let's check our understanding here at the end. Again, there's a lot more description in the tutorial. I encourage you to take a look at it, especially around the things we did with testing, because again, all we did was kind of an introduction to Swift testing. So be sure to check that out. Okay, select the true statement about test methods. They need to be annotated with tests. That sounds right. You can't use the expect macro inside them. That's not right. They're easy to write after you've correctly implemented the method under tests. Nope. Remember, you write the test failing first before you implement the method. So let's choose that one. Perfect. Which of the following view modifies, hides a view, but only when the property should hide is true? So, okay. So we have hidden, disabled, and opacity. So in this tutorial, we talked about disabled and we talked about opacity. When we disabled the value, the view, it changed the look of it, but it didn't hide it. So it's opacity, where you set the opacity. If should hide is true, then we set the opacity to 0. Otherwise, we set it to full. So that is a common way to conditionally hide a view. Unit tests are for testing your app as a whole, as if you were testing it directly on your phone. And I'm going to say false. The reason for that is a unit test is much smaller than that, only testing specific types and methods in your application. Sweet. All right. Thanks again. I know this was a long one, but I appreciate you sticking with it. Thank you for liking this video. Thank you for subscribing. And I will see you in the next video.